Hello everyone and welcome to Learning Minds. My name is Jyoti Nigam and I am a software engineer. So this is the ninth video of Elasticsearch playlist and I would recommend you to watch my previous videos and then come to this video. So in this video I will be telling you about the problem of concurrency. So when we are dealing with distributed systems like Elasticsearch, we can run into problems with concurrency. What is this problem? So what will happen when two different lines are trying to do the same thing at the same time? So these kind of problems are concurrency problems. So we'll be talking about how to deal with that in Elasticsearch. So let's say we have two different clients and they are running a web application on a big distributed website. So say for example, they are maintaining page counts for any given documents that are viewed. And we'll call those documents pages on a website. So let's imagine that two people are viewing the same page at the same time on a website through two different web servers. So basically at this point, we have two different clients and they are retrieving a view count for the page from Elasticsearch. So let these may be the two different clients and they are requesting for the view count. So what will happen is when they are asking at the same time, they'll get say the view count is 10 right now. Before that 10 people have come over to this page. So they get the view count as 10. So to write a new update for this document, they will increment the view count to 11. But in actual, the view count should be 12 because there are two clients viewing the document or the website at the same time. So it should be 12. Now, how do we solve this problem? So this is a real world problem that can happen in Elasticsearch a lot of times. For example, two people can try updating the document at the same time. So what? So the solution to this problem is that when the client requests for a view count, instead of only returning back the view count, Elasticsearch also sends sequence number and a primary term associated with it. So these sequence number and primary term together form a unique chronological record for this given document. So if say client 1 comes and client 2 also comes, so client 1 counts the view count as 10, the sequence number 9 and primary term 1. Now client 1 will try to increment it and client 2 will also try to increment it. Say client 1 increments it, so now the view count will be 11 and accordingly the sequence number and primary term will change. So say sequence number becomes 10. Now when the client 2 tries to increment using the sequence number and primary term, it will get error saying that uh, the sequence number conflict or version conflict of the document. We see this in terms of code just within a few minutes. So what will then client 2 do? It will repeat the process. It will again try to get the view count for the page. So when it again tries to get the view count of the page, it will get the new view count that is 11 and the new sequence number and primary term. So when this tries to implement that view count, it will then succeed. There is a parameter called retry on conflicts which retries to the number you specify, and we don't need to specify this process explicitly. It happens by default. So let us just see this in action. Now in the code. So I have uploaded the commands required in the Git repository, and I'll provide the link of the same in the description so that you can access those commands. But I would also recommend you typing these commands on your own for your practice. So I'm running Elasticsearch, and now let us create a new movie. So we'll copy this command and paste, and we'll create a new movie with genre sci-fi and IMAX, title Interstellar, and year 2014 in the movies index. And the ID over here is 10. So this new document is created. You see, you get back sequence number and primary term. So you can also use this get command in case you are doing it for an already existing movie or already existing document ID. So now copy this command. Here we are doing a put request, and we are trying to update the title of the movie using this sequence number and primary term condition. Mm. Over here, we'll change. Also remember to change the sequence number and primary term to the one you get. So in my case, I got sequence number as 16 and primary term as 4. So yeah, just press enter, and you'll find that the result is updated and charge successful. So now the movie title would be updated. If we do a get command and check it, we'll see the updated version. Yeah, now you see the title is changed, and you also see that the sequence number and primary term is changed. Now the sequence number has become 17. So now if we try to do it second time, say the second client got the sequence number 16 and primary term 4, and client 2 is trying to update it. So what will happen? Client 2 will get this version conflict, and you see the current document has sequence number 17 and primary term 4. So this request will be discarded. So only one client at a time will be able to update the document. Now I told you we have the retry on conflicts parameter. So let us use that. So in this request, we have retry on conflict is set to 5, so it will retry 5 times, and we are only updating the title of the document, something else. So if we try to do this update using the update API and we using retry on conflict, you see that now this is successful, and it says that result is updated, and you get a new sequence number 18 and primary term is 4. So this entire process is called as optimistic concurrency control, and this optimistic concurrency control, that is using the sequence number and primary terms, is the solution to the concurrency problem. I hope you have understood this, how it works. Do like, share and subscribe this video and comment below your views. Thank you everyone.